Hi, welcome back. So let's talk a little bit about the science of historical geology. First off, let's talk about where geology comes from. So geology is a branch of earth science. Earth science including astronomy, oceanography, meteorology, environmental science, and geology. What's fun about the earth sciences is that when getting a degree, if any of you are interested in geology, I actually had to study all of this other stuff as well. So it's kind of cool. It's kind of interrelated. There are some differences. There are some, specific courses that pertain more to others depending on your particular career pathway. My master's degrees were actually in meteorology and geology. So kind of these two. But I had to study all this other stuff as well. But when looking at geology, you can go many different ways. In fact, I am more so in the geophysics realm because I have a bachelor's degree in physics as well as my master's degrees in geology and meteorology. So I kind of ended up in geophysics, which is why I study kind of mostly structural geology, the way things are formed, natural hazards, planetary science. So I've taught classes here as well from time to time on planetary science, the geology of other places. Yeah, natural hazards, natural resources. That's Geology 110, another class that we teach here periodically. But in any case, this course is about historical geology. So what is geology? Well, it comes from the word geology is derived from a couple of Greek terms. Geo meaning earth and logos meaning reason. So the reason the earth is the way it is. So that's the study of figuring out why earth is the way it is. Hence geology is the study of earth. There you go. So typically, most of you perhaps have maybe already taken physical geology, Geology 101, which studies Earth's materials, such as minerals and rocks, as well as the processes operating within the Earth on its surface. How volcanoes work, how earthquakes work, that kind of stuff. So that's more physical geology. That's Geology 101. However, this is historical geology. So in historical geology, we study kind of changes in our dynamic planet, which we've kind of already talked about, how and why past events have happened, and the implication for today's global ecosystems as well as into the future. So we can look at geologic evidence on, climate change, how that might be happening naturally now, but also how humans are further driving or kind of creating a human-based climate change, etc. So some of the principles of historical geology really aid in interpreting Earth's history. And just like general history classes, to understand the past helps us understand the present and also the future. Same thing with historical geology. Now, it's all rooted in a number of kind of concrete theories. So first off, let's talk about what a theory is and what a theory is not before I kind of talk about some of the concrete theories that geology as a science, specifically historical geology, is rooted in. In everyday society, the way we use the word theory is incorrect. That's the colloquial usage, how we kind of use it kind of in everyday kind of random discussions. So we use the word theory incorrectly, and we use it kind of to mean speculation or conjecture, like your guess or your opinion. So if someone was to say, I don't know, Friday nights are better than Saturday nights, and someone would respond, "Oh, that's just your theory," meaning, "Oh, that's just your opinion, that's just your guess." But that's not the correct usage of theory as it pertains to science. The scientific usage is actually almost the opposite, where we use the word theory kind of like opinion, which is very low-level knowledge. If I say, I don't know, tacos are the best food, something like, "Oh, that's just your theory. That's just your opinion." I mean, tacos are pretty damn delicious, but right, that's just based on my choices and my wants and needs and my opinions. But that's not like concrete. There's no evidence to say that tacos are the very best. So the way I'm using that word theory is actually incorrect, because in science, the scientific theory is actually the opposite of opinion, which is low level, or speculation. It's actually the highest level of knowing. So in science, the word theory is a coherent explanation for one or several related natural phenomena. It's supported by a large body of evidence. So theories are the highest level of knowing in science. So let me just kind of break it down. So simply put, a theory can kind of be broken down into 5 things. It's the highest level of knowing in science. A theory is testable. When you run those tests, the outcomes are repeatable. You always get the same results. A theory has never been proven false. And a theory is widely accepted. That's as good as it gets. For example, the Big Bang Theory. Oh, that's just their theory on how the universe started. No, dum-dum. You're using that word incorrectly. So now you look even more stupid. So the Big Bang Theory is it's a theory. It's the highest level of knowing. There's repeated tests for it. Those tests and evidence are repeatable. It gives us the same results. The Big Bang Theory has never been proven false. It's never been proven false, and it's widely accepted. Now, I want to be careful, because just because something has never been proven false doesn't mean it's true. We don't often use the word true in science. We kind of stay away from that word. The reason being, the beauty of science is that it changes. With new evidence, new information, our understanding changes a little bit. Let me give you an example. Gravity. Gravity is actually a theory, gravitational theory, right? I let go of this pen, it falls down. Our understanding of gravity and how it works, kind of from the ideas of Sir Isaac Newton, a little bit of physics, kind of worked pretty well for a few hundred years. But as we, got more advanced and more information, the formulations and the equations for gravity and how it works, it's not really quite right how Sir Isaac Newton came up with it a few hundred years ago. Along came Albert Einstein, and said, you know what? Gravity is kind of a little bit different. It works a little bit different. Here's a little bit different equations. Here's some different stuff. A little bit more refined. And that's a better explanation of gravity and how it works and the mathematics behind all of that. So science changes, right? And that's the beauty of it. So we don't really use the word true. We have a body of evidence in front of us. We can run repeated tests, and if everything is repeatable and we're getting the same results and we can't really prove it false, then it works. It works for now. And it can change. And some people point that out. Well, that means, you're not 100% sure. No. This is the highest level of what we can be. But again, with new evidence, that might change. All right. So, theory, highest level of knowing. Theories are testable. Those tests give us repeated results, the same repeated results. They've never been proven false, and they're widely accepted. Theory of evolution, never been proven false. Again, this is a little bit different than saying true, but it's never been proven false. So there are 4 foundational theories to historical geology, and we'll kind of work those out here in this first unit, just to kind of introduce you, just to give you a foundational knowledge to build on. So first, I mentioned one, the Big Bang Theory. Then we'll get into something called the nebular theory, then plate tectonic theory, and the theory of evolution. So this is going to kind of build that story. Big Bang Theory, starting, so the beginnings of the universe. The nebular theory, how our solar system formed. Plate tectonic theory, how the Earth works. Evolutionary theory, how, organisms have changed on the surface of the Earth. A lot of that, again, can be connected. The biosphere is connected to the lithosphere, the hard surface of the Earth, so the connection there. So that's kind of the story. And we're going to start that story all the way back at the beginning, the birth of the universe. And that's what we're going to tackle in the next section. So we'll pause here, and I'll see you back here for section 4, the birth of the universe.